Welcome to this tutorial on bond rotation in Jmol. In this tutorial, we will learn to use tools in the Model Kit menu to rotate bonds. Use script commands to rotate specific bonds in a model. Create models of anti, gauche and eclipsed conformers of 1,2-dichloroethane. Here I am using Ubuntu Linux OS version 20.04, Jmol version 14.32.80, Java version 11.0.16. To follow this tutorial, the learner must have knowledge of high school chemistry. Must be familiar with basic operations of Jmol. For the prerequisite Jmol tutorials, please visit this website. The most prominent conformations of 1,2-dichloroethane are anti and gauche. Anti-conformer is more stable when compared to gauche. Eclipsed conformer is unstable. These conformers are interconvertible by CC bond rotation. Here I have opened the Jmol application window. Let us create a model of 1,2-dichloroethane on the Jmol panel. Click on the Model Kit menu on the toolbar to get the model of methane on the panel. Make sure that carbon is selected in the Atoms panel in the Model Kit menu. Click on any one of the hydrogen atoms in the methane model. This creates a model of ethane. To do the energy minimization, click on Minimize option from the Model Kit menu. This will display the more stable anti-conformation. In the Model Kit menu, now select the chlorine atom with symbol Cl. In case you don't find chlorine in the options, then do the following. Click on the option which shows question marks. An input box opens. Type the symbol of the element in the input box. I will type Cl for chlorine and click OK in the input box. I have selected the chlorine atom. We need to replace one hydrogen atom on each carbon with a chlorine atom. Rotate the ethane molecule in such a way that you can see the Newman projection. Now click on the hydrogen atoms that are opposite to each other. The hydrogen atoms in the model will be replaced by chlorine atoms. Here is the model of anti-conformer of 1,2-dichloroethane. Exit the Model Kit menu. To view the labeling of atoms, open the console from the File menu. At the prompt, type Select All and press Enter. 8 atoms are selected. Type Label On and press Enter. Close the console window. The labels for all the atoms are now visible. Let us measure the dihedral angle between the two chlorine atoms in this model. Rotate the model on the panel so that you have a clear view of the C1-C2 bond. Double-click on the chlorine atom on C1. Then click on C1. Next click on C2. Then double-click on chlorine atom on C2. The dihedral angle of -180 degrees is displayed on the screen. This model is staggered 1,2-dichloroethane. We will save this model as a mol file. Open the Model Kit menu. Click on Save File option. In the dialog box, select the file destination. I will select the Documents folder. Select Files of type as .mol. Name the file as anti-dce.mol. Click on Save button. We will create models of gauche and eclipsed conformers by rotating the CC bond. To create a gauche conformer, we need to rotate the C1-C2 bond by 120 degrees. There are two ways by which we can achieve this. Using the bond rotating tool from the Model Kit menu, typing Jmol script commands on the console. Let us first use the bond rotating tool. Open the Model Kit menu. Click on the Rotate Bond radio button to activate it. Click on the bond connecting C1 and C2 atoms. Hover the mouse over the C1 carbon atom. Rotate branch C1 message is displayed on the panel. Click the C1 atom and rotate it. Stop rotating when you see the dihedral angle between the two chlorine atoms is -60 degrees. Users may rotate the carbon atom accordingly. This conformation of 1,2-dichloroethane on the panel is gauche. Save the model as a mol file using the Save File option in the Model Kit menu. Give an appropriate file name and a preferred location. I will select the location as Documents folder. Select Files of type as .mol. I will type the name as gauche-dce.mol. Click on Save button. Let us rotate the gauche conformer to show its Newman projection. Back to the gauche conformation. Let us use script commands and create a model of eclipsed conformation. Close the Model Kit menu if it is open. Open the console window from the File menu. Type the following command at the prompt to select the bond connecting C1 and C2 atoms. Press the Enter key. Next, type the following command to rotate the branch attached to C1 carbon. This command will rotate the C1 atom in the anti-clockwise direction. The number 60 indicates the angle and 30 is the speed of rotation. I will resize the console to show the model. Press the Enter key. For more details on script commands, please use the following web links. Please watch the video on script commands. It is available on Spoken Tutorial website in the Jmol application series. Back to the Jmol panel. Close the console window. The model on the panel is of eclipsed conformation. The dihedral angle between two chlorine atoms is 0 degrees. Save the model as a mol file. Use the Save File option in the Model Kit menu. Give an appropriate file name and a preferred location. I will select the location as Documents folder. Select Files of type as .mol. I will type the name as eclipsed-dce.mol. Click on Save button. Let us rotate the eclipsed conformer to show its Newman projection. Let us summarize what we have learned. In this tutorial, we have used tools in the Model Kit menu to rotate bonds, used script commands to rotate specific bonds in a model, created models of anti, gauche and eclipsed conformers of 1,2-dichloroethane. As an assignment, explore the rotate command to create the models of conformations of N-butane. The video at the following link summarizes the Spoken Tutorial project. Please download and watch it. We conduct workshops using Spoken Tutorials and give certificates. For more details, please contact us. Please post your timed queries in this forum. Spoken Tutorial project is funded by the Ministry of Education, Government of India. The script for this tutorial is contributed by Snehalata Kaliappan. This is Madhuri Ganpati from IIT Bombay signing off. Thank you for watching.